first of all, it is best to write your general word equation. And this is something like acid plus base would give you salt and water. So we'll start off with that. We'll write that acid plus base gives us salt plus water. So this is our general word equation. So first of all, when you see a chemical reaction, you should identify it as a neutralization reaction or a combustion reaction or an oxidation reduction reaction. So first of all, you would identify the reaction and write the general word equation. What you then would do is specify the word equation. In other words, you look at what are the chemicals that are reacting and what products are going to be formed. So in this case, we're going to take an example. We'll take hydrochloric acid as our acid. So hydrochloric acid, which will be reacting with a base. We'll take sodium hydroxide. When those two react, they form a salt. And how to work this salt out? You have sodium here, going to react with the chlorine. So it'll form sodium chloride. Sodium chloride. And also water, because water is a product. So this is our specified or specific word equation. It's in words and it's an equation. Then what you would do is write your chemical word equation. In other words, you would figure out the formulas or the chemical formulas for each of these and write it out. So hydrochloric acid is HCl. And then our sodium hydroxide, as we all know, is NaOH. Then this would produce sodium chloride. Sodium chloride is NaCl. And water is H2O. Now, how to figure these out? HCl. Go to your periodic table and you would find H is in group 1 and Cl is in group 7, which means that each of these have a valency of +1 and -1. Remember cross-multiplying or crossing the two together. So you would cross these around and you would get H1, Cl1. Remember, you don't write your ones. So you would cross out the 1 from each and you would get HCl. And that's how you would go about writing a chemical formula for your compound. We'll take another example. We have NaOH. NaOH has a sodium ion and an OH ion. Now the sodium, if you go to your periodic table, you can find it under group 1, which means it has a valency of +1. OH is one of those anions that you should remember the valency of. There are a few and you should remember them, but as we come across, we'll just memorize them. So for now, just know that hydroxide, the hydroxide ion, which is OH minus, has a valency of -1. So it'll be -1 like that. Now you would cross them together and you would get Na1, OH1. Again, you don't write your ones in because they're just 1. You would rub them out and you would have NaOH, as you can see here. And you would apply a very similar method to your sodium chloride because sodium is in group 1 and chlorine is in group 7. So you would cross them out to get Na1Cl1, which is eventually going to be NaCl. Now water is simply H2O, as we all know, and that's something that's universally known. So let's go to the next step. Now since we have a chemical equation here, the next step is to balance our equation because balancing is very important. Now to balance the equation, what you do is you would consider the number of atoms on this side and consider the number of atoms on this side. We'll first start off with our H, which is a hydrogen. We have one H on this molecule and one H on this molecule, giving us 2 hydrogen atoms. And on this side, we have 2 hydrogen atoms from our water. So we have a total of 2 hydrogen atoms on each side, so it's all balanced. Moving to our chlorine or the chloride ion, we have 1 chlorine atom here and we have 1 chlorine atom here. So our chlorines are balanced. Let's move to our sodium, Na. So sodium, 1 of them here and 1 over here. So that's 1, 1 making them balanced. Now let's move to our oxygen. We have one oxygen on this side of the equation and we have one oxygen on this side of the equation, making the oxygens balanced. So this is one of those equations that are already balanced for us, so we don't need to balance it further. However, it is very important that you check it before. So before you move further, you have to check whether it's balanced, and that is a very important step. So I would call this a very important step. The next step is to write your states. So to write our states, that's our physical states, we have to know which state each of these chemicals are going to be in. So first we have hydrochloric acid. Now acids and bases are usually in their aqueous form. In other words, they're going to be ions in solution. So we are going to write a little AQ next to aqueous, hydrochloric acid, because AQ stands for aqueous. And then we have sodium hydroxide, again a base. So bases are usually again in aqueous form. So you would say AQ. Then we have sodium chloride. Now you would know this by the end of the year that sodium chloride is going to be aqueous because you'll be learning the solubility rules. But before that, just remember that sodium chloride, which is a salt, and usually most salts are in aqueous solution, so AQ. And then we have water. We know that water at room temperature is going to be liquid, so you would write a little L next to it. So that's how you would show the physical states, and that's how you would balance a chemical equation. Now let's move on to an example to write an equation for the reaction of hydrochloric acid on solid sodium carbonate. Now this is a different reaction to what we just did. It is using hydrochloric acid with a carbonate. Remember that acids with carbonates produce carbon dioxide. So that's why with your general word equation, you would write down what are the products and also what are the reactants. We have an acid reacting with a carbonate to produce a salt, water, and carbon dioxide. Now you would write the chemicals that you're going to be using. So as our acid, we'll be using hydrochloric acid. As our carbonate, we'll be using sodium carbonate. As our salt, we'll be using sodium chloride. As our water, we'll be using water. And carbon dioxide is going to be the gas produced. So that's just writing in what we got here, or the chemicals that are used and the chemicals that are going to be produced in our reaction. Now you would turn this word equation into a chemical equation. So to write your chemical formulas, we know that hydrochloric acid is HCl from before. Then sodium carbonate. Now carbonate is one of those anions I was talking about before. So first you would write your sodium and your carbonate. Carbonate is CO3. Now sodium has a valency of +1 because it's in group 1. And carbonate is one of those ions again that you should remember. So the valency of the carbonate anion is -2. And that is something you should remember and memorize. So write it down somewhere so you remember, along with your hydroxide ion, which has a valency of -1. So now if you cross them along, as you would work out the chemical formulas, so you would have Na2 and CO3 with a 1. So because you don't have to write your 1, it's going to be Na2CO3 as you got here. Then we move on to sodium chloride. Remember, sodium chloride is NaCl because sodium is group 1 and Cl is in group 7. So they both have a valency of 1. We have water and carbon dioxide being produced. So that's our chemical equation. Now that doesn't stop there. What do we have to do next? Is to balance our equation. So to balance our equation, we have to see how many of each of the atoms, whether it's balanced. So we'll start off with our carbons first. How many carbons do we have on this side? We have 1 carbon from our sodium carbonate. And here we have 1 carbon from our carbon dioxide. So the carbons are balanced. Let's move on to hydrogen now. We have 1 hydrogen on this side and we have 2 hydrogens on this side. So our hydrogens are not balanced. So to balance our hydrogens, what we do is we put a 2 in front of the HCl. So we have 2 hydrogens now. Do you see that? So it's all balanced, the hydrogens. Now let's move on to our chlorine ions. We have 2 chlorine ions here because of the 2 we put in front of the HCl. And then we have 1 chlorine ion here. So we have to balance our chlorine ions. In order to do that, we put a 2 in front of our NaCl. Now let's balance the sodium ions. We have 2 sodium ions here. And we have 2 sodium ions on this side as well because Na is times by 2 due to the coefficient of 2 in front of NaCl. Now let's balance our oxygens. We have 3 oxygens on this side and we have 1, 2 over on this side along with this giving us 3. So we have our oxygens balanced. Now that is a balanced equation. As you can see, it's written 2HCl with 1 molecule of sodium carbonate giving us 2 molecules of sodium chloride, 1 molecule of water and 1 molecule of carbon dioxide gas. Now what you would do is you would have to write your states down. That's our last step, to write the states. Now remember, the state of an acid is always aqueous. Sodium carbonate, it's already given to us saying solid sodium carbonate, which means it's going to be a solid. NaCl is aqueous, water is liquid, and carbon dioxide is a gas, so it'll be a G. So your chemical equation would look like this. You would have 2 hydrochloric acid molecules which are being in aqueous form reacting with the sodium carbonate to form this. So you can see the G representing gas. Now let's move on to a question. 6 grams of magnesium metal is burnt in air and converted to magnesium oxide. So in this question, we are supposed to find the mass in grams of the magnesium oxide. Now they have given you the atomic mass of magnesium as 24 and oxygen as 16. Where they have derived these masses from is, go to your periodic table, and if you go to magnesium, which is Mg, you would see 24 written there. Now this is the atomic mass. In other words, how many protons and neutrons there are in the atom. You would find the same thing with oxygen. It'll say 16 on the oxygen box. Now let's see what the first step is. The first step is to write a balanced equation for the reaction. So we have to go back to the reaction and see what's happening. It's a burning reaction, which means it's a combustion reaction. So magnesium is going to burn along with oxygen to form magnesium oxide. And then we have to balance our equation. Now this is balanced for you, but if it wasn't balanced for you, you would have to go, the magnesiums are balanced. And then we have 2 oxygens here, but we have only 1 oxygen here. So you'll put a 2 in front of the MgO, but then our magnesiums are not going to be balanced, so you would put a 2 in front of the Mg. So that's a balanced equation. Now after writing a balanced equation, you would go about trying to get all your data and all arranged so it's easy for you to work on. It was very important to get your relevant data. Now in this case, we're given that the magnesium metal is used is 6 grams. So 6 grams of our magnesium metal is used. And then how many grams of magnesium oxide, which means we're going to be comparing the two. So we'll be using our magnesium mass to find out the mass of the magnesium oxide being produced. So you would write your answer like this, so it's easy to compare. Now we have 2 molecules of each, because from our balanced equation we can see 2 molecules of magnesium are used to form 2 molecules of magnesium oxide. So you would write the 2's. Now what happens is, now you have to times the masses. So we have 2 atoms of magnesium used. That means 2 times 24 are being used. The next one is 2 times 16 plus 24. Because magnesium oxide has a magnesium atom and an oxygen atom, we have to add them together. So magnesium is 25, oxygen is 16, giving us a total of 40. So 40 times 2. Then you would just simplify it. 2 times 24 gives you 48. 2 times 40 gives you 80. And you would compare your results like this. Now go back to your question. You're given that 6 grams of magnesium metal is used. So you would write 6 grams under your magnesium column. Now you don't know the value of the magnesium oxide, and that's what you're after. So at this stage, you would try to isolate your X. And to do that, you would use a ratio and solve it. So we would say that 48 over 6 is going to give us 80 over X. And you would cross multiply this and try to isolate our X. When you isolate X to one side, if you solve it further, you would get 10 grams. And this is a simple calculation. Now you would never leave your answer at this stage because this is not correct. It's only saying that X is 10 grams. But what is X? We haven't given a value for X yet or a name. So for your last step, you would write a statement. And in this statement, you would say 6 grams of magnesium produce 10 grams of magnesium oxide. So in this section, what we covered was how we work out our mass to mass statement, as well as how we looked at our chemical equations, and we studied a few reactions such as a combustion reaction and the neutralization reaction.